Hello everyone, my name is Ayush Manish Pise and today we are going to learn what is federated learning in deep learning. So let's get started. Now let's understand why federated learning was introduced. So federated learning was developed to solve one major issue in AI, that is data privacy. In traditional machine learning, all the data is sent to a central server for training, which risks the exposure of sensitive information. Federated learning changes this by allowing models to be trained locally on users, devices, or different data sources. The key idea is to collaborate with or without data sharing, meaning organizations or users can jointly train a global model while keeping their data private. For example, phones learn typing patterns locally and share only model updates, keeping messages private. So now let's understand what is the main concept behind federated learning. So federated learning is essentially a distributed learning framework. Instead of sending data to the cloud, it sends the data to the devices called as clients and trains the model on its own local data. These clients then sends the data only on the model's learning patterns or updates us to a certain central servers. The server aggregates these updates to improve the overall global model performance. This process repeats until the model converges, ensures that the sensitive data remains secured on the local data or on the servers. For example, hospitals train model on patients' data locally and share updates to build a common diagnosis model. Now let's understand how federated learning works, means how the data is secured while convergence. So the first step is initializing global model on central server. In this step, the server creates a base model for training. In the next step, it distributes the model to multiple clients, which means clients receive the model to train locally on their local devices and computers. In the next step, the client trains locally and sends the weight updates. In this step, the clients takes the weights and each client improves the model with its own data. Then in the next step, the server aggregates all the weights, which is a good example of federal average algorithm. In this step, the server averages all the updates and provides the best performance to the model. In the last step, each update is repeated until convergence takes place. This process continues until the model gets the perfect accuracy and stabilizes to give the best performance. Now let's see what are the challenges or limitations that are faced by federated learning. Federated learning being powerful, it goes through some issues which are first, communication overhead due to multiple rounds of data exchange. This means high communication cost is needed for frequent data exchange, which slows the training. Then next is non-IID, that is non-identical data across clients, which affects model accuracy. This means varying client data reduces global accuracy. The next threat is security threats like model inversion or poisoning attacks. This means model updates can be attacked or tampered by the attackers. And the last challenge is it requires stable network connectivity and computation power. If the client is not having a good device, the client will lead to updates. The client will receive delayed updates and the model will not get trained accurately. To summarize the whole concept that we learned in today's session, so the federated learning is represented as a major leap towards privacy preserving artificial intelligence. It allows organizations to train shared models without exchanging sensitive data. The decentralized approach enhances security and compliance while maintaining high model performance. Federated learning is especially valuable in fields like healthcare, finance, and mobile applications, marking significant move towards ethical and responsible AI development. Thanks for watching the video.